Yeah. We are back. So this macro results in the layout comes from this one, which is here, which is the layout of the tuple element. Yeah, I don't want to have the layout. I want to have the member. Me needs the member tuple. Which is called members tuple. So I'm going to use that instead. And no layout. Data has now a members tuple. And we strip off. Hey, Polo, how are you, man? We strip off the layout wrapping here. Let's see. Now I have tuple elements of containing class struct layout. Oh, I cannot parse this. Hold on a second. What's the declaration type? Members tuple. Okay, I can still not parse it. Yeah. Pretty sure this belongs to the layout. It's just a layout, yeah. Then what is the tuple element layout type? I think that the tuple element is a struct member, isn't it? Or maybe member layout. I think that's what I want. Let me strip off the layout type as well, but then I even have to strip off the tuple element. Is that true? No, it cannot be true. I just remove the layout type, that's it. Okay, so tuple element T, member index of that thing, right? I think that should work. But I have to remember what I just removed because I'm pretty sure I need it again. Let me try remember that. So I do a redo. Undo, I mean. The undo is I add layout type and then layout around it. Okay. So that came from the base class, which is this GLSL data, which now has a members tuple. And we pass that to the second template argument of offset, align, and resize, which is not found. Why not? Seriously? Ah, right, okay, so this is now members tuple. And I do no longer have a members layout. Nope, this does not make any sense whatsoever. What? Good morning, Bear. Undo everything. I don't know, what am I doing? I got confused again. It's unbelievable that this is a template. I was like, huh? Members tuple has already member index applied, but it doesn't. It just tells it where to apply member index when you pass it to this type. Okay. So redo again then. So here, this worked, so I have to reconstruct, as it were, what I just removed, which was that after the member layout, I need to add layout type. Yeah, I forgot it. Okay, let's see if I still have an undo here. Nope, it's gone, it's all gone. Right, so maybe you can see it in the diff, because I cannot remember it. I'm just going to write it, I think, and then top here. Layout type, what was it? To redo this, I have to add layout type behind it, and then wrap the thing in the layout, right? I have to say that looks really weird that I would apply member index like that. Now I just started again. Member layout. Members layout is what is passed to the second argument of offset. God, what it is. Members tuple. Yeah, and that came simply from. That is just this type thing here. It is a template. A template type. You know what? I have the feeling that this is indeed what we want. That looks extraordinary strange. Extraordinary strange. I've never seen two template parameters after another like that. And here I need the same thing. So well, what I was doing was wrap it in a layout after passing layout type to it. Append a layout type after it. Yeah, well, that's how it is for now. Well, I meant members tuple. I renamed the thing. Still, I made members tuple. Sorry, I made members tuple a template. So it just dived into it. That should be like this, of course. What I thought, it looks so weird. I think this is a lot more likely to work. Now I have to specify that this is a type name. Yeah, this is a type. If you have double colon, that means that a member of. So we have a type, and this type is a struct, and the struct has a using or a type def. And if we want to use that, we just use the double colon. So now this is a type defined inside this struct. And then you have to put type name in front of it if this type here depends on one of the template parameters. Now it obviously depends on this one, what is being used here. And it depends on this one. The reason is that the compiler has to know that this is a type before it instantiates this template. So it doesn't know what this is, and therefore it doesn't know what this is. But it needs to know if it is a type or a non-type. That's how this works. So when I see the double colon here, and I know that it is dependent on template parameter, I put the type name in front of it. If it is a type, of course. For example, alignment is not a type, it's a size type. So here there is no type name in front of this. For size, the same thing. Yeah, I'm giving C++ lessons. Everybody happy? Well, I think we have something that has more chance to work than what I just had. Required padding now gets a members tuple. And what I really wanted to pass to it was a members layout, or, well, I don't, but something that gives me an offset and a size. If you ask me, that is I think simply this. Members tuple applied. And I get the tuple element. Those are struct layouts, I think. What I would really like is to have the member layout, because there are struct members. Not sure. I don't know anymore where I was using one type and where the other. But okay, I'm just going to pass the members tuple here as well. So let's rename this thing members tuple. And if then I apply the member index, then we hopefully get something that does have an offset. And if not, then we at least will know what the type is. Tuple. Tuples. What did I do? No is. What? Members. Tuple. Tuple. Okay, we have it. Finally. Let's try another compile. Layout was not declared. Did you mean, okay, so I just didn't specify the namespaces that are required here. 499. Member layouts was not declared. Yeah, it was members layout. More typos to follow. It was members tuple. That's what I meant. Members tuple. Didn't rename this one. And there's another one here. Is that also members tuple? No, I'm not sure. Maybe required padding needed the members tuple, but the other stuff doesn't, right? So I just have to do the same thing as I did here. So alignment and resize, for example, takes t, whatever t is. No, it doesn't. Layout, takes a layout there, second parameter. Not a members tuple. So yeah, we have to do it again here. To do it a lot of time. I have to do it so often that I would like to, you know, maybe add some little thing to do it automatically, which is very possible. I'll first do it in full and then we'll make an abbreviation for it. Okay, so now I suddenly have two of these things. Why is that? I think one is enough. And then here again. Yeah, normally I would say do like inside the class, you know, you just make a few const expressions, or rather inside the class, that was a function. Make a few const expressions, maybe even use a few usings things, and then you just build it up like that. But in this case, we're dealing with base classes, and this is the class that I want to define, and then it is this class is derived from this base class and this one. So there is no place here where I can, there's no scope here where I can construct these things. Define things rather, define types and then reuse them. I could do that here, of course, but yeah, once we are inside the body, I just have to do it one more time, so I might as well do it then. So this must be wrapped also in layout with, I think, layout appended. Kind of feels weird. I have the feeling that on this side I paste the less than, and on the other side I don't. How can that work? So I'm missing one, right? Definitely missing one here. I'm also missing the type name now. Type name. Yeah, this is better. That last one belongs to the align and resize. We don't have that here. Okay, so we look if that compiles, or shall I make an abbreviation immediately? So what I want is that instead of typing this whole thing, we make a sort of a function, but then for types. So we make a template, something, and then struct something, and then we define it, and then we use that instead of this. So let's say duplicate this line, and I'm going to write what I want to write. We're going to name it let's say yeah, we have to use a members tuple, because that's a, we don't know what it is. It's a template parameter, and we have to use member index for the same reason. So this is like a given. But then we want to convert this thing. So conversion is then another template, or template function or anything. No. And then we put something in front of it which is like a function. So it's converting whatever you pass to what I need, and I need a layout. I can just use layout, I guess, without the namespace. So this gives me the layout of that thing. That's what I want. I'm going to call this layout. And the thing that we pass is the result of applying member index to the members tuple. There was the members tuple. If we apply that, we get the tuple element, which is God knows what. I think that's a member struct. Maybe that is a member layout, but I'm not sure. That very well could be. Or is it the struct layout? No, there's members tuple is a tuple of all member layouts. Yeah, that's what I added. No, I didn't. I guess it's a member layout then, right? Yeah. That's what it says here, idiot. The member tuple is a tuple of member layouts. So if I pick one tuple element from it, then I get a member layout. Right. So now I want to apply, so this is my function, this is the argument, okay? And I want to apply the argument in the same way as we did here. So I need to get this type here. And then the members tuple member index, which is this thing now. And then the rest. See, so this thing applies basically what we did here. Append layout type and then wrap the whole thing inside layout. And the whole thing means the whole thing. So like that. No, I did it wrong. Oh, I did it wrong. Oh, well, I think this one must be. Yeah, this is how it is. So we append layout type and then we wrap the whole thing in layout. However, now this is gives us a struct and not this thing. So now we have another trick. I think this is also a template. Think about how to name it. So this is like, say we have in the standard we have things like standard is same, which I cannot jump to. Let's see if we can look this up. Yeah, see, this is so what the struct is equal to is same, and that implements it then in a way that, well, as if it is a function, as it were, and then they define an is same v. Which then returns that internal, well, here it's called value. This is, however, a boolean and not a type. So now I'm wondering if that is really necessary then. There are also things like types, I think. You do not the v, but you do _t. Like which ones do exist? Maybe the enable if is a good example, which didn't work. Yeah, that's more like it. So in this case, type is a type, and then they add an extra thing that has an _t appended to make it even shorter and simpler. So I'm going to do that as well. Let me call this thing, like the standard it's just type, and I'm going to call this one layout. And then I'm going to define a using that is called layout _t, which is then the same as here. So that is type name, layout, apply, template parameter, type. And now we can use that here. And well, he did win a little bit, not that much, but a little bit. So then I can apply that 3 times here. Substitute all of this. I made a mistake here. There is a angle bracket missing here. The line resize. So what we wanted to do was member tuple, lines, yeah. So I think it's just an angle bracket at the end here missing. Isn't it? Well, I don't know. Let's try again. To substitute, let's take this one, wrapped type name thing with that applied, including the less than, and we replace that with layout type applied to member tuple, like that. It is not very clear, I have to admit. Let's put that here, maybe like that. Nah, maybe not. How to format such a thing? The beast. Yeah, I don't know. But this might also be a good style. I always remove spaces there, but I can't say that is very readable. You can hardly see what belongs to what. Also like to, let's say, if I do this, then I usually would like to put the matching angle bracket down there. So that would be like this indeed. But it feels a bit silly to then immediately put that on the next line. But yeah, what can you do? And now this one, maybe I should then this one also like this. That looks better, at least. Now it's kind of clear that you have a line resize with 2 template arguments. And this one has also 2 template arguments. Okay. By now I forgot what I was doing, so it's time to recompile again. Smiler Man, I have no idea. I forgot it. I forgot what I was doing. Yes, I have Discord. So a new invite necessary. Let me get it. I must say I never look at the Discord. It's more for people to continue chatting after the stream ends. But hello. It's always, oh no, I stepped over it, buried under OBS for some reason. I should just minimize OBS, I think. Let me find the invite. How do we get an invite? Invite people. Copy. Okay. I should just minimize OBS so now I can see the Discord as well. And all the other chat things. But hey, it doesn't compile. Required from what in instantiation of const eval is size type GLSL required padding with members tuple is data top position. Members tuple. Int member index is 1, size type long unsigned int, required from. Size is not a member of members tuple 0, aka vulkan shader builder member layout. It is a member layout. Top position, vulkan shader builder basic type layout, standard 140, e float 114466040, that's our data, with the string top position unused 1. Well, you gotta be kidding me, right? So what was members tuple? Well, actually we have an offset now, but no size. How is that possible? So the offset worked, but the size didn't. Well, I have to wrap that inside the layout then. So I'm gonna move this above. It's just hard to imagine that something has an offset but no size. What are we talking about here? Member struct. Let's see that in a minute. Layout type. Now we get the size from that. Members tuple 0, aka member layout. Let's have a look what member layout then is. Member layout here. Alright, member layout has an offset but no okay, yeah. I could look inside the layout type and stuff, but I'm already doing that actually. Yeah? So we have this thing, I put layout type after it, then we get the X layout and then we get the size from that. Whatever. So that seems to make sense. That indeed did only have an offset and no size or alignment. The best scamming site. And Nightbot is slow as hell. taking longer. Hey, it compiled. And it doesn't work. It compiled, but it doesn't work. Okay. Disappointing. Did it really compile? Well, not working is probably the same as saying that my assert still fails. The assert that I commented out. Let's start with that. And I have to really go back to it should work. Uncomment this, which checks if the offset is correct. What I'm basically working on is trying to get the offset of V correct automatically. So if this doesn't compile, then we still failed. Yep, we still failed. So the offset should be 16, but it ends up to be 8 for some reason. And now I have to find out why it is 8. That's pretty annoying. Yeah. So called GC. Maybe you should just type in the general so that other people can see it too. Why is this wrong? Stuff like this is so hard to debug. Okay, I'm going to expand the macro again, I guess, to begin with. The macro is really this, and the member type is then the vec3. And the member index is 1, and the member name is v. And I'm having a lot of other members which use the same type. That's going to be maybe too hard to debug. So I think that what I do is just add a 2 behind this. So really specific for this case. And I'll just duplicate this and then debug that. So I make another one here, and then we'll call this one too. And then going to comment this one out, I think. Yeah, I want to jump to it, but I don't want to rename it. Otherwise, maybe I'll forget it. So now I have to do this, then I can jump to it. So here's the 2, and then what goes wrong is that the offset inside this class is wrong, right? I'm not sure what the offset should be. The offset should be, what did it say, 16? It should be 16, right? Yeah, it's a vec3 in standard 140 that has an alignment of 16, so we must end up at an offset of 16, and this has a size of 4, so we need a padding of 12. So required padding here should return 12. And in order to debug that, you'll guess it, I'm calling it 2 as well, and we'll just make a duplicate of required padding. Well, this is something else. We're looking for this one, a function. Yeah, duplicate. Code duplication, absolutely horror, but in this case it helps. And we're going to delete it again. The code duplication. Wait a minute, what did I do now? Undo. Oh, yeah, it's up here. No, isn't it? What the hell? Everything went wrong. But seriously, I was trying to make a duplicate of this thing here. Why did it not want to do that? Why? P. Required padding 2. And okay, so if the member index is 1, then it should return 12, correct? So I'm going to add here static assert. What it returns must be 12. Poo-poo. Hubba bubba. 46 years. Of which 28 years in C++. What? Yeah, I need to start jingles, you know. So a short hallelujah. So hallelujah, hallelujah. And I need a Twilight Zone down. Ding, ding, ding. How does it go, that Twilight Zone tune? I would almost think that the assert didn't fire because it compiles. I mean the static assert. And therefore we're going to make sure it fails, as in make it 13. Oh, great. So it's at least calculates 12. So we do get here, and it is 12. Therefore, we return 12. I'm going to do something which is so trivial that I should not be doing it. But I just want to see every value succeed. If this is 16 and the previous offset is 0, and the previous member size equals 4, then I'm going to forget about required padding 2. This, I mean, of course this worked, but you know, then we check every value that we don't accidentally end on 12 for some completely random reason. That works. So let's just delete the required padding 2 because it works. So that means that my aligned padding here gets as first argument 12. Maybe the alignment that it gets is 16 or 4. No, don't tell me that it's something like that. Well, let's just see what it gives. Well, maybe I can guess that. This is alignment of the layout of the member, current member. So this is indeed 16, I bet, and the size is this is a vec3, right? Size is 12, so this is 4. Yeah, the DCD returns 4, I think. So this should be a base class with 12 and 4. So let's debug that. I'm just calling it 2, I guess. Going to call it 2. Let's make online padding. Why do I have multiple things? Oh, this is a reflection test. Okay, so then we go here, and I have a definition and a specialization for a size of 0. Do we make that duplicate of that? No, there, and then call this one 2, specialization 2. And then I do not forget to make this a 2. Good one is immediately jump back to it. Now we have the 2 here. And if this is called with a non-zero padding, which would be this one, oh, it's the other one's just never 0. Static assert padding equals 12. I'm not sure if you need that text, but I think you do. Alignment equals 4. That's what I expect anyway. Still looks like magic. I mean, that it doesn't work. If this adds something with an alignment of 4 and a size of 12, then the next element is just going to be at an offset of 4 plus 12 is 16. Not 8, never 8. Impossible 8. Compass. Okay, well, I have to check again if we get here at all, so let's make this a 3. Yep, you get there. Well, that means that this is really a character array of 12 characters. Which then means that this base class must have an offset of 12 relative to the beginning of this struct. Okay, I'm getting it. Yeah, okay. Yep. It's the assert is wrong. It says that the alignment is sorry, the offset is 8, but it's, I don't know. Actually, it was at 4, right? It should be 4. I think it was 4. Yeah. It's just taking the offset of this thing, and I need it to compare it with the offset of this base class. And then the only way to get that is to add, I don't know, let's just add something. Let's say static const expression offset as a function. It's never needed. Offset off, so not a keyword. And then I think the class and then the member, or the class is ourselves. Well, this is just it. So I'm gonna, let me first remove all the 2's again. So align padding 2 can be removed. And then the offset and the line resize 2 can be removed. I think I need to change the value of this offset really. That offset must be adjusted. Yeah. I think this line is correct, but that value is incorrect. No, it's nonsense. Sorry, nonsense. This is wrong. Yeah. So instead of using offset off, I cannot use offset off. So that's the trick. What I have to do is just get the type of V. So I can do declaration type. And then we can get the offset of that, something like that. Yeah, so so the declaration type of V is offset, align, and resize. This is V, and this is the type. So I want to add simply an offset to this type. To add a static const expression, size type offset. And that offset then must be equal to I guess the offset of the previous member plus its size plus this offset. No, what the hell? What is the offset of this thing? I can fill it in, but I'm not testing it anymore. This is really just to debug the code that I'm writing. So it's different, right? It's really, yeah, it's debug code. I'm going to add a if def tw debug around it. And then I'm going to call this debug to make sure that I understand that it's debug only. And what I want to know is Maybe I should just return the size of this thing. No, I want to have it really accurate. That's difficult, or is it not difficult? I can cast this to the best thing would do to cast, I think, the current type to this type, and then we get an offset. Debug offset. Okay, let's call it internal offset. And I just want to have the offset from the beginning of this struct to the beginning of this base class. I think if I cast a pointer, of course it's a pointer. So I'll take this, which is a pointer to that, and then I'm casting it to with a static cast to this base class, and I'm not sure if I need the full thing. I could just try it like this and then hope that it understands that I mean that thing. Nah, probably not. Let's just add a full thing. T, comma, and then all of that. Pointer. Well, that is then a pointer, but it should be equal to the offset. So I think I can reinterpret, cast that to a size type. This is probably not officially supported anymore by the standard. This many casts. But I'm pretty sure it works for my compiler, and it's only debug code anyway. So if it compiles, then I think, well, if it compiles and works, then I think we did a good job here. So that's the internal offset, and then we have to add that to the offset of top position, comma v. A Vulkan engine is an engine that makes Vulkans. Sorry, just too many people asking it. Invalid use of this at top level. It could have worked, I would say. Yeah, not only that, it's just exactly not what I want. Let's add another reinterpret cast, evil laughter. No, not type, the null pointer. Let's just cast this to the current class. I think that should work. So it is a template, but if I not use template arguments here, I'm just going to use whatever the current class is. So you don't have to repeat the template arguments, at least I think so. Let's see. Not enough sleep. When am I finally going to write this FAQ? Invalid cast from type standard null pointer type to GLSL whatever I want. Really? Okay, it takes a while to compile this every time, so let's just write a small test case here to play with it. Let's use one box. So I have a struct A derived from B. Really? And therefore we also have a struct B. I wish I wouldn't fill in things that I don't type. Super annoying. Character padding 12 characters. And it's also derived from C. Struct C, which is not empty. I don't know what this contains. Let's put a float into it. And this thing is empty, and now I want to know what is the offset. I'm going to make a static const expression size type. And the debug internal offset, aka offset, and well, yeah, offset. Okay, offset of C. And then I don't know. And then I'm going to print that value. So we create an A. No, I don't even create an A. I just print the value. Standard out. Offset of C is. And then we do a double as offset, right? Yep, and we do this by, so that should print 12. I'm doing this by calculating the, starting off with the, so we end with a reinterpret cast to size type. Now That should work. Just cost 12. It doesn't. It doesn't want to cast into size type. Oh my god. Okay, you give an unsigned to you. Still not. Oh, it's what? They have a whole different meaning of reinterpret cast than I do. Really. Seriously. When I think reinterpret cast, I mean, dude, just cast it. I know what I'm doing. But no. Oops. What the hell? This is not even a cast anymore. But okay, whatever. Next try, we're going to cast a pointer. And the best pointer I can think of is a void pointer. Now, hopefully, please let this work. Wow, that works. Okay, so at least we can reinterpret cast a void pointer to a size type. And I think I can cast a void pointer to a static cast a C pointer. Nope. Void pointer is not allowed. A cast from void pointer is suddenly not allowed. Well, then I make it a character pointer. Show me who is boss. It is also not allowed to cast character pointer. Static cast not, at least. Yeah, okay, because it's static cast. But a reinterpret cast would work, right? So let's start with the reinterpret cast. Reinterpret cast. Does that cast character pointer? It's not a const expression. What? Where? How? What are you talking about? Reinterpret cast is not a constant expression. That's new. That is utterly new. We're going to back to trying a void pointer. Hell, I'll make it const. Even conster. Well, that doesn't matter, I guess, but getting desperate. Type qualifiers ignored on cast results. Okay. Reinterpret cast is not a constant expression. It sticks to this. It's really making our life difficult, isn't it? I mean, things you can do in C is just do whatever. And I want to do whatever. And C should be a part of C++. But I don't think that's the case anymore. If I use a C cast, it's just going to try all the other things. It's going to try static cast and then reinterpret cast. It's probably not helping us. Nevertheless, let me try that. So in C, I would just say, dude, give me a C pointer. I don't give I don't give a shit. Just you have 0, you get 0 and cast it. And now do it. Bet it's not working. It's not working. Oh, that for a different reason. Try this again, this time with the correct number of parentheses. Oh, it works. Okay, flabbergasted and stuff. Reinterpret cast. So I can cast a C pointer to a size type. That's nice, isn't it? Now I can make an A pointer as well. That also works, of course. Yep. And now you can do a static cast from the A pointer to C pointer. And now it says cannot convert from A to base class C because A is incomplete. Right, it's incomplete because we're in the middle of A. Yeah, that's true. I have to add a stub. So just going to add a b. This is the b for base, and then you're going to do the struct a is simply derived from a b. Cannot convert a to b because a is incomplete. Sorry, I meant ab. Can conversion from pointer C pointer to arithmetic size type is suddenly no longer possible. I went through all this trouble to make sure that I could cast a C pointer to a size type, and it worked, as long as the pointer was 0. And now it's non-zero, it's not working anymore. Okay, then we're going to do maybe I can cast it if I subtract a 0 pointer from it. I think one pointer minus another pointer is a pointer diff. That should work. So let's subtract. Well, let's subtract what we did before. So C pointer 0. And now it complains invalid cast from long int to size type because it's not unsigned. I think I have to use a static cast for the signedness. So you can do a signed size type, and then do static cast to the size type. And now I get 0. Oh, that's surprising. But at least it compiles. That is something. I would think we get AB, though the AB pointer is A, and then if I cast that to a C, that should be the size of B. And the size of B is of course 12. And then 12 minus 0 is still 12, and then cast etc. It should have been 12, but it gives me 0. Why? Isn't it guaranteed a memory layout to be the pointer to B is equal to the pointer to AB? Pretty sure that. Let's sandwich it. Still 0. That doesn't make any sense. No. They haven't talked for 2 hours. It's a bad sign. One box is this online compiler where you can compile little test snippets. Okay, maybe the trick with the 0 is too much to ask. Although I think it just should work. Well, a static cast should know that it is a multiple inheritance. So I expect that if I static cast 0 from AB to C, that I get the offset of C in AB, which should be equal to the size of B, aka 12. So this C pointer should be a pointer to the address 12, in my opinion. Anyway, I'm going to now do it with objects. So we make an AB, and then we make an AB pointer. And then I'll just print it. Let's print the AB pointer. Jeez, calm down. Why did it not make this as a pointer? So one character was wrong. It flooded me with 3 pages of errors. the hell? What the hell is this, man? What the hell is it? Need more Twilight Zone. ABP might be undefined, so it doesn't make any sense whatsoever. I'm assigning it here. Well, if someone sees it, please tell me, because what is this warning? I do get a value. I just have an object here, right? The object has an address. I assign this thing to that address to this pointer here. Totally correct. And then it is going to tell me that it might be uninitialized. What? Ridiculous. Yeah, even make it const. It's completely impossible to have an uninitialized const. Tell me again that it is uninitialized. ABP may be used uninitialized. Dude, it's const. How can that be uninitialized? This is a compile error. Give me a good error, a good compiler. Let's switch to Clang 15. Okay, this makes more sense. Const expression variable offset must be initialized by a constant expression. Apparently that's not the case. Reinterpret cast is not allowed in a constant expression. Ooh. Yeah, everything, absolutely everything is good. Well, no, not everything. So I guess I should say no. Okay, to hell with it. This is way too difficult and a way off topic to what I'm really trying to do. I'm just going to do what I know is correct given whatever compiler I'm using, etc. and in practice and stuff like that. The internal offset is equal to the size of the first base class, which is kind of obviously going to be equal to size of this base class is simply whatever we are passing here. Alignment of V, yeah. Someone is printing 12 here. Oh, yeah, PG is another pretty smart guy. Okay, new attempt then. I already deleted it. No, I didn't. This is just attempt. The problem is if you subtract it, it's going to say, yeah, hey, wait a minute. No, it's not. No, it's not. I'm subtracting C from C pointer. No, it's not. I thought it was subtracting AB here, but so the example that he gave, there it is the case. He made it an UN pointer type. Yeah, okay. So I guess what he is showing here that it doesn't matter if you point to a real object or to a null pointer. This is a null pointer, and then you get null. And if it points to a real object, you get 12. That's crazy. So how does it determine if it is a real object? Maybe by testing if it is null or not. In which case, we could change this to, let's say, I know, something non-null, 64 and 64. It still says then const expression. Reinterpret cast is not allowed. Well, that was just for the size, so for the sign. I think we have a standard, so I'm just casting it to his. There is a standard remove assigned or add unsigned or something like that. But we'll just use assigned. Now what did I say? Const expression also must caster performs the conversion of a reinterpret cast is not allowed in a constant expression. Okay, so this is interpreted as a reinterpret cast, even though it is a C cast, C style cast. Yeah, no deal then. Okay, go away. I hate C++. And then we'll just do this. Set it to required padding. Yeah, I know, people, I never needed any motivation. Not one single external motivation needed. Nobody told me to go programming or whatever. I just found a PC in the city and in the shop, and I started coding. And then at some point, my dad bought a computer, and I started programming, not playing games or anything. There's no programming and learning, reading books about it. I devoured the documentation of that computer. I think, especially at that age, you just absorb everything. Got everything out of it that was in it. It's never bored. So if people feel like I have to code but I don't want to, that is not an experience that I've had ever. So maybe I want, but I would almost say then maybe it's not for you. If if you're not like obsessed with it. Static exertion failed. Offset of V is wrong. Still, whoa, yeah. Now it's 20 is equal to 16. Oh yeah, the offset. Yeah, okay. The offset of V is 8 because of the alignment, I guess. It is not as easy as I thought. Okay, let's assume we fixed the assert. Doesn't even work then. Does it even work? Not sure if I tested this already. It doesn't work. Okay, so maybe the assert is fixed and the 20 is unequal 16 and therefore does not work. So what we can test is the offset of V inside of top position, and I expect that to be 4. Or not, yeah, of course. We just, unless the alignment is larger. So if the alignment of V is set to 4, and I think it should, oh, wait a minute. It is the alignment. No, it's not. I have an alignment of 1 for my padding. It's taking way too long, this. It's no fun anymore. It is 8. So for some reason it put V at 8. Why did it do that? Why did it do that? Let me check the alignment of V. We can check that. So align off. Is it align off? Is the alignment 8? Nope, it's 4. So the align is 4 and the offset becomes 8. That makes no sense whatsoever. So the align is correctly 4. The offset should also be 4. Because the size of top position unused 1 should be 4. If the size of the first member is 4 and the alignment of V is 4, then the offset of V should become 4, right? So maybe the size of the first element is not 4. Yay! The size is 8. What? I have a single float and the size becomes 8. Which of course is because my padding cannot be 0. I think I have... yeah, that's it. I think I know it. The solution. Okay, I understand it. The problem is that this offset align and resize, if required padding is 0, okay, we pass 0 to aligned padding. I should get this, and that's an empty struct. But since this is a base class and I didn't mark it with non-unique address, it gives us a size of 1. So this base class cannot have a size of 0 because then it cannot have a unique address. So I'm not sure if I can mark a base class as non-unique. Otherwise I just have to specialize this whole thing, I guess, somehow. Yeah, that's not easy. Express this one into yet another template where I pass the required padding, and then specialize that for a value of 0. Either that, or I can use no unique address for the base class. I'm just going to try it. Well, this I guess this is it's impossible that this compiles, so I'm going to try it anyway. Yeah, it doesn't work. Yeah, and then we can still try. Damn it. I can still try adding it to the class itself, either before or after. I don't know if that's possible. Well, actually this does have a unique address. It would be the specialization that then is somehow must be marked with no unique address, but I doubt that will compile. I'm making a Vulkan engine. Don't ask me what a Vulkan engine is. Google it. Attributes ignored. Yeah, well, okay. So that doesn't work either. Then I'll have to specialize this thing for a value of required padding of 0. Which means we're going to have to, let's say, yes, I'm working on a Vulkan engine. Need the Vulkan engine, a Vulkan engine. It's like a game engine. Offset, align, and resize equals padding, align, and resize. Yeah, no. So from something like this spam bot, you really see that YouTube, aka Google, is really only interested in making money. They don't give a shit about how good things work. Apparently it's not harming their revenue that we have to look at spam bots all the time. They only have to put like one guy on it to make it harder to run these spam bots. Or implement anything, because this is the same spam bot. Again and again and again and again. So the account survives for many days, and the first one survived for weeks, if you ask me. What do you want to be when you grow up? I want to be a Vulkan engine. offset line and resize equals, I think that should do it, right? So you just express our offset align and resize into something else. Padding, padded, align and resize. And then we can rename this thing to that padded. And now we have here as a first thing the required, well, I don't know, required padding, but that's a function name. Padding, whatever. And then this is the padding. And this is GPS. Is the internal offset really equal to the padding? I don't think so, because it depends on the on the alignment of this thing. So we would have to compute it. I need to get the alignment of this thing and then round that up to a multiple of, no, we get this thing and then round that up to a multiple of the alignment of this thing. But that's way too difficult. So I'm just going to delete it as soon as this works. This debug internal offset has to go, I guess, after it works. And now I'm going to make a specialization of this template. Where we drop the padding because the padding is 0. And then the rest is still what it is. And in that case, we don't have a padding at all. Please compile. I must say I'm getting tired now. Tired as in losing my motivation. It's like I don't like it anymore. Thank God. We have it working! Yay! So, like I said, I'm going to get rid of the debug internal offset. I don't want to put this anymore on separate line. Separate lines. Okay, what is pre-padding? Padding is usually padding is something that you put after stuff. So how do you call it when you put it in front of stuff? Oh yeah, of course. Padding in front fastening brass. Front fastening brass. Yeah. That kind of padding. How do you Google this in a safe way? I need a computer science specific. I don't know what padding meaning then maybe. Maybe it says that it can also go in front of it. Yeah, someone I see said it's still padding. I'm not English, I don't know. Okay, I'll just still call it padding then. I'll call it pre-padding here to be clear, but still, it's padding. Padding is putting unused bytes in front of some object to give it the correct offset. I also have post padding to give it the right size. It just works. Yes, it does. I'm gonna look at my git diff now. What else can I throw away? There's a load of add minus p edit, I guess. No, I don't want this. Want oh, I didn't test this yet. In fact, this cannot work anymore, right? I mean, offset of v plus debug internal offset. That would be required. If I'm going to delete that, then it better is be bug free now and never fail anymore. Let's try this one. Align and resize became offset align and resize. Yes. Loads and loads of new code. Probably should find a better name for this thing here. It's a bit short. It's only used in one place. It's kind of a help function, and all it does is convert. Get the layout from the layout type, whatever that may be. Yeah, okay, I'll just leave it. I don't want to make this one long. The whole point was to make it short. Well, I guess we want to commit this. That was all. Let's get rid of this. Let's first commit everything else. Whippies. And then get restore paranoid minus paranoid. Discard this chunk. Yeah. Now we have get status that is clean, and I can push it. Can't even do a clean up. Extra clean. Oh no! What do I do? Everything is deleted. Up to date. Git status. That's what I meant. Everything is clean. Okay. That has to compile again. It's really compile file. I think it's file, right? Doesn't compile. That's shocking. Debug internal offset is not a member. I guess I removed it. Did I remove it? Yeah, well, that was 2 years ago, I believe, when I started this. And now I realize that it is so much work that I don't think I will have time to write a complete Second Life year out of it. I will just never get there, unless loads of experienced people will join me. I cannot do that alone. It's a million lines of code. A complete viewer. think in my absolute top productivity is 1,000 lines a day. It seldom happens. I have days that I write 2 lines. So it's completely impossible for me to write a million lines of code. Now I already have a lot, but it doesn't help that I'm a perfectionist. I don't want to quickly hack something together that works. I want to write the fastest, best, bug-free thing that can possibly exist. And then it really takes a lot of time to do. I'm still stuck on this. It doesn't. My debug internal offset is gone from. It should not be the case, I think. Not getting it. Oh, I deleted it. Or I renamed it. Did I delete this? No. Yes, I did. I did delete it. Okay then. In that case, no more assert. I just have to trust blindly that this code is now bug-free. No asserts. So this is how we write it. And now even vec3 works. This is really amazing, I think. Yes, thank you. Applause. Please jingle with clapping people. Well, I don't know. Shall I test other things, or is it just, do I believe it now? So if I add another float in between here, we have to eat dinner. Then it should stop working despite the alignment. Okay, so this should stop working because I'm not adding it here. It is a silly test. That's interesting. You can't request a size that is less than the actual size of t. Ha! That's a big size. Padding becomes negative. We need a negative padding. I'm not sure I understand this though. Oh, wait, I think I do. No, I don't. Well, yes, I do. This must be a 2, otherwise it doesn't match that factory. And then nothing works anymore because I'm missing a memory that's just not working. I'll just have to go all the way, put everything in. Can't fool around. So this should work just as fine as the other one. Not enough sleep. And his name is John Seal. I need more jingles. Okay, let's do something funny. I'm going to make, let's delete this again. I'm going to make this a vector of size 7, and then we're going to use the seventh vector thing, seventh element, right? Is that a good idea? Let's just actually make it the size of 7, like 7. Don't use hard-coded constants like that. Also code duplication. Zip. Okay, so we're going to use the last element, which is 6 of the 7, and then the 0 gets the x out of it. Let's switch to Z. I don't know, it's silly maybe, but then this becomes a Z. And the V is now an array of vec3s, and we use the last one. Why? Why is it not working? Jesus. Not really being used though, but I made too many changes once, I suppose. Nevertheless, shocking. Okay, I think that the reason is that arrays do not have pre-padding support yet. So that's why a vector of vec3 would fail. An array of vec3 would fail. If that is correct, then I think it should work if I turn it into a vec4, because that does not require any special treatment. And I still use Z, the Z element. Nope, also doesn't work. Then what did I do wrong here? I don't think I made a mistake here. Anyway, let's go back to X for a start. Not too many changes at once. Although that can hardly make a difference, right? Nope, not working. Well, then I really need my asserts then. We need asserts. So the big question is always, is the offset of my vector correct or not? Now, I'm pretty sure that the padding here should be set to 0. Hell, I can just remove this. Remember, make it extremely simple. Well, that's kind of stupid almost. But if removing the first element makes a difference here, then clearly the problem is in the offset again, still. Or I never tested arrays of vectors, I have to say. So maybe it just not working. Okay, this works. So then the problem is really the offset. Now, from the top of my head, I would say that vec4 must be aligned 16 bytes because it's a vector. Sorry, because it's an array. For the STD 140. And we should have no padding. I wish there was a way to print types during compilation. I can make a hack. Maybe I should add the hack to the debug library that I have. Just pause the type and then print it. It's not a bad idea, really. Yeah, let's do that. Let's say I want to print a full type of of V, type of V. I want to print the type of V. Let's do debug, print type. top position V. How silly is this? I don't think that compiles. Let's do it like this. Declaration type. So we call a function here that is a template and we pass it the type of V. Let's call it static, just like static assert. Okay, remove the type because then it reads more like English. It's a type anyway. Static print that type. What? Finally. That is debug, but well, maybe someone changes it and stuff like that. This is in cwds/debug.h, so this is a good place to add it. As long as we are inside that namespace. Let me look for a namespace. We are inside that namespace, only when we have a debug start. Debug specific code. And where does that end? Probably as at an end or something. Mark structure namespace debug end. Okay, so let's add it here. Template. Type name T. Void print. Static print. Something like that. And I can fake an error. Maybe what if I just do error? No, that's probably not going to work. I need a static assert or something like that. That depends on T. So the size of T equals 0. It's not the most clean way, but for now this should work. Yeah, Kevin, you mean input. You just want to press a key and then immediately read the key, right? I don't think there's explicit support for that, but I'm not sure. depends on the operating system. So I don't know. You need unbuffered input maybe. You have to Google it. My take would be that you need a library for it. I mean, for example, if you would run a console application, then your program just doesn't get input until you hit enter. So you have to tell the terminal that it must send every character. So you need a library to find out what terminal the program is running in, and then how to tell the terminal that it must send every character. So that has nothing to do with C++. Not really, I mean. Now I've seen everything. Someone not only watching my stream, but not understanding what I am saying. How can we suddenly get an error? It doesn't compile, so I know I cannot run it at the moment. Well, I should go eat. I think I'll do that. Like I should just stop the stream at 6 sharp. Go eat. But why? Why? I didn't change anything. I just added the assert, right? And then we get this error. Oh. It was still a bug though, so I have to try to use a vec3 or something on. Well, it's still an interesting error though. No, I put the vector first as well. Quite from here. No type name element X layout in X layout type struct vulkan basic type layout. Yeah. Very confusing. Well, I don't know, man. I really don't. I want to see it. I mean, so if this is 0, it does compile when I have nothing in front of it. We did that before. Well, that works and this works. And then I ever use a null and null, I suddenly get a really, really weird error. Okay, well, I don't know. Right now I want I want this to work. Maybe it doesn't know debug namespace. It should know that if I include debug. Debug.h. Right, let's undo everything. And then add include. Nope. Expected constructor, destructor, or type conversion. Just use a simpler type. No, I don't know. Maybe. Oh, huh? Yeah, okay. I'm an idiot again. Okay. Yeah. The anything goes thing. It starts to get ugly, right? 121. What's with 121? It's saving up my error. Oh, there it is. Okay, so now it prints a double. Yay. Very deep, but it does some sort of. Because I'm too lazy to type the M. Static assertion failed. T is that thing. Twenty 28 years. Required from here. Well, it's nice that we can see now that the padding is 12. What is this one here? What is a memory index? Okay, the size of this thing is 128. It's also interesting to see. That would be the size of the eigenmatrix. I would hope is 16, just simply the size of float times 4. This means 4 rows and 1 column, so this is a vector, and it says matrix, but since number of columns is 1, it's a vector. So the size of this thing is, I think, 16 times 7 plus 16, because we have a padding of pre-padding of 12, and in front of that there's another float of 4. So in total I would expect 8 times 8 is 64. So for some reason it's doubled the size. It's twice as large as I would expect. Or is it? It would be nice to have a better way to see the memory layout of these types. Using compiler errors just doesn't cut it. I think I'm going to write a little test application that simply prints me the exact layout of everything. So it must be an application that is able to create these kinds of types and then do something with it. But first I'm going to eat, and then I'm probably going to play on my tablet again, a few games, and then I'll be back later. Okay guys, so where's OBS? There it is. Bon appetit. Eet smakelijk. If you still have to eat. How did I get 64? Why I thought 64? Well, better to look at the top position. So the size of a float is 4. It's printing. It's just printing the size of t. You're right. So it just be the size of v. But okay, still, this must have an alignment of 16, and this has a size of 4. Therefore, the type that member creates is a character array of 12 followed by an array of vec4. And since vec4 is then forced to be aligned at 16, it's going to have 16 bytes in front of it. Okay, I'd have to say it's pretty dubious at this point, but I was assuming 16 byte in front of it, and then this is 7. So if this is also 16 bytes, then you get 128. Okay, yeah, thank you, man. Yeah, you're right. I was mistaken. Yeah, it's 8 times 16. That's 128. Yeah. That's why you see I need a break. For some reason I was multiplying 8, and then suddenly I was multiplying it by 8 instead of by 16. So the total expected size would be 8 times 16, 16 being the array stride that is being used here. So the 128 seems correct. Except that it shouldn't be. I think this is also our bug. I cannot use pre-padding. You even made me found a bug here. I'll explain that. What I think now is, so this struct here, the top position struct, so it's struct top position. And then we have a float, unused one, wrapped in a type, but it's it has the same size and the same alignment as a float, so it might as well type float. But then we get another type, which is some type, some object, which exists of an array of vec4 or eigen matrix float 4,1, but okay, that's a vec4 with a size of 7. And I put an character array in front of it with a size of 12 padding. Oops. Now if the alignment of this thing is super small, like 4, then it works. If this is just packed connected to that, then the distance so this is just going to be 16 then. Then that's what I want, because I want this thing to start at offset 16. Must be offset 16. But what happens is that I have a tag this thing with an alignment already. The alignment must be 16. And now C++ says, oh, then this object must have an alignment of 16. Therefore, this point must have an alignment of 16. So now C++ is going to add $12 bytes here to get the alignment correctly. And then this becomes, yeah, and another 4 here. So I'm ending up with a total offset of 32 instead of 16. Okay.